In this video, I'm going to be talking about mutations. DNA translates to mRNA. mRNA then codes for amino acids which make up proteins. Sometimes, though, DNA can mutate, which means to add, remove, or change a base. The results of this mutation can be catastrophic or have no effect at all, and in this video we will focus on point mutations, which is changing a base. An analogy I have for this is a mom teaching a baby how to talk, where the mom is the original DNA and the baby is the mutation. And so if a mom is trying to teach a baby to say the word mama, and the baby says the word mama, then this would be no mutation at all. But if the baby says nothing, then this would be a nonsense mutation. If the baby says mommy instead of mama, while it is different, it generally means the same thing, so we could consider that a silent mutation. But if the baby says something completely different, then that would be a missense mutation. If the mom says, okay, now it's time to stop talking, but the baby continues to talk, then that would be a read-through mutation. And so this is the DNA that we have. The bottom strand is the coding strand, which I've shown 5' to 3' here, and it translates to this in mRNA. Looking at a codon chart, we can see that AUG codes for the start, and this codes for the stop. Here we have the start, and here we have the stop. And so for right now, we're going to focus on this area. When the DNA has no mutations, it codes for M, V, R, F, K, then stop. And so if we have a missense mutation, which could be, for example, going from C to G in a transversion, we now have a UUC coding for a UUG. And so it goes from MVRFK to MVRLK. And this is just showing the mom saying F and the baby saying L. A nonsense mutation, which could be a transversion going from an A to a T, which then translates to a U in RNA, we go from a K, AAG, to a stop, UAG. And so this causes a premature stop. And so if the mom says, say, MVRFK, and the baby only says MVRF, that's a premature stop. If we have a silent mutation, which could be going from a C to an A in a transversion, C going to a GUA, well, that still codes for the same exact thing. So there actually is no difference in meaning, and this is what I meant when I said that mutations could actually do nothing at all. And so this is the mom saying GUC equals V, and the baby saying GUA equals V. Although it's different, it actually does mean the same thing. A read-through mutation could be a transversion going from an A to a C, and so what was a UAA is now a UAC. And so it's not a stop, but a Y now. And so because the mRNA codon is now a UAC, it no longer codes to stop. Now it codes for Y, S, T, Y, and it continues. And so this is the baby saying MVRFK, Y, S, T, Y, and it continues to read through. These are my references. Thank you for watching.